Okay, this would be Servo Controls Part 4. So this will still be using the virtual chassis that we have in slot 0, and is using the exact same logic that we have. We put in the started putting in video 2 and video 3. So this is done on, again, this is to kind of go over it again. It's virtual axis 1, virtual axis 2, virtual axis 3. And we still have our resets that do our shutdown reset, fault resets, homing. We have our MAM, we have the move to position, we have our jog feature. Now what I would like to highlight, and the reason I'm doing this video, is to show the ability to change a single servo while it's running. Instead of having to stop the servo and change the speed, you're able to use a MCD instruction, a motion change dynamics, and you're able to use that to be able to change the speed while the servo is running. So some of the things I'd like to highlight about that is we are using a type of a jog. So you can use, say for instance, you're doing it on a MAM, you could do a MAM. We're choosing to use it in this simulation as a jog feature. So while the servo is in a jog, we're going to issue the speed change. So real quick, I'll go ahead and start the reset it from a shutdown state. I will, after the state transition to 1, home it, and if we homed it, so real quick I'll show the axis properties. So after I homed it, remember we put the home position at 100, that's 100 units. Now it is in state 2 now, so we can go ahead and move to position. I'll go ahead and uncheck or untoggle the axis or jog axis. So we'll toggle the move to position push button, and this is in process at this point. So the instruction is done. It is in process. The servo is moving to the position of 500. So, and again, that's a trapezoid. So in the position of 200 or 500, as soon as it reaches 500, it will do a process complete, which is axis MAM process PC, and it will transition state 3 into that state machine into state 3. Okay, so now it's at a point where we have hit our 500 position. So it moved the servo to a 500, and at this point we want to jog. So we press the jog button, we start the jog, we do the in process bit to transition out of a jog state to the next state. Now in this state we have the motion change dynamic. Now you have to put the update speed bit or a bit to break the enable of this actual instruction. You have to put that in there, or else it will not be able to update the speed. So if you look at the way I have the instruction, or the rung above it, if it's not equal, if the actual jog speed is not equal to the previous speed, then it will take the update speed OTE to a state of 1, which will then cut the bit on, and it will break the enable. Now this is just for one scan cycle, so it's very quick. So you see the speed changed. So if you look right over here, you'll notice that the speed changes. No. So what happens is this update speed bit right here breaks, and it breaks the enable, which makes the instruction have to re-instruct on the next scan cycle. Now say for instance we took this update speed bit out. So if we did that and we chose to change the speed, it would not work. So keep in mind we're running at 15 at a velocity of 15. If I go to 20, it changes here, it changes here, but the instruction itself did not change and make the servo go a different speed because it did not cycle. It did not break and did not reinitiate again to give a second speed. So to show that again, I'll go to 30. So everything did what it was supposed to. However, the servo continued running 15. Now, if I put the bit back in, the update speed bit back into the logic, then everything will resume back to working properly. Now, of course, as I did an assemble right there, it did not change the speed, but that's just because it was still in the routine. So you see the speed changed as soon as we did that. Now we can take it all the way down to 1. We can even take it to negative numbers so we can get it running backwards. Now I will note that if you happen to enter in a speed of 0, now the servo is still running, still in a run status of in a jog state right now. So it's running, however, you cannot change the speed out of a 0 state. If you do, it will error out the command. So it will error out the motion change dynamic instruction. Now the reason it does that, and we can go up and pull up the instruction help. And we can look up the error code that we have. So at the bottom of the instruction help you have a motion error codes. Now what we can do is go to the monitor tag and see what the actual error is. So our axis 1 underscore MCD dot ERR is 23. Now in 23 we look at that error and it says that an instruction attempted to do an illegal change of dynamics. So it's kind of vague on why, you know, it went into an error. But I will say this: to get out of the error, all you have to do is cut the servo off. So take the jog, depress the jog button, do the jog button again, and it starts back. So it resets the motion dynamic or change dynamic instruction. So at that point our error bit cleared up, everything changed, and the servo started running again. So you can see that the virtual axis 1 actual position is moving, and you can see the actual velocity is at 5. We have our speed at 5. Now that's even with the jog command having a speed of 10, because we are actually dynamically changing the speed with the MCD instruction. So if we took the speed to 15, it would go back to 15. Everything would start moving faster, the servo did not have to stop. It continued to run. Now I will say, the one thing I'd kind of like to highlight right here is the speed units, and the units per second is what it's currently in right now. Now say for instance we took that and changed it to a percent of maximum. So if we changed it to a percent of maximum, you would think that it would probably work the same way. Well, you'd be correct if you thought that it would change the speed. Now what will happen though is it will actually change the speed double what you put in. So say for instance I put in a value of 20 for my axis 1 jog speed. It's going to actually change the velocity to a velocity of 40, and you see it changed the velocity to 40. So if I were to go 25, it would go to 50, and then if I went to 10, it would go to 20. Now even if I went negative, if I even ran it backwards, it would go negative 20. And this is because it's in a percent of maximum. So we actually have it set where it's going to actually run double what you put in the value. So if we take that right back to 10, it's going to run 20. But so there are instances where you want to run a percent of maximum. I would say it's probably rare. It's just, so most of the time you're going to see it where it's a units per second for the speed units. And when I say that, it means that every speed or every command, like say for instance every unit you tell it to run, it's going to run that exact unit. So if we told it 10 or if we told it 15, it's going to run 15. So it matches up. 1 per 1 is actually the ratio of that. So if we went 20, it would go and run a speed of 20. So just to kind of give an instance of this video is basically giving an instance of one servo and running in a jog scenario. If you wanted to change the speed, just to highlight the fact that you do not have to stop it. You can change the speed by having a MCD instruction, and the MCD instruction has to be broken, has to have the enable broken by a speed update or some other manner to be able to constantly update that. You know, you could probably do it a lot quicker. This is generally how we see it done, like a not equal to. That way it highlights or makes this OTE cut on, which takes that update speed bit high and then breaks the command for the instruction. Now you could actually, you could probably have the enable on. You know, you could probably take and put something like this. I will say this is probably a little too quick. You know, this would probably work. It's just going to keep, every scan is going to constantly go off and on. So if I change the speed, yes, that will work. However, you're using the processor way too fast. You're actually you're over scanning a process that you really don't need to. So even though the motion attribute right here, even the tag, the motion group update rate, the attribute for the course rate update is at 4 milliseconds. We have the main program running at 25 milliseconds. Now, what's updating first is always going to be the motion. However, we're using more of our processor at that point. So it's not best that you use the command like that. As far as using the enable, yes, it will work, but you will use more processor you will utilize more of the processor's ability and kind of just bog it down. So you generally want to have, say for instance, something that just is being used when you need it and only when you need it. I mean, you could put timers in there, you could put whatever you want in there, as long as it's not as quick as the natural scan time of the processor. So again, just to highlight, change the speed, that works fine. Then we come down here, we can stop it. Everything still stops exactly the way it should. And then we do a shutdown. So with the shutdown, that took, let's open this back up, that took the virtual access 1 into a shutdown status. So the state machine went into a 0, and we would have to reset it to start over. Now what I have done is I did the same style logic on Servo 2. So on Servo 2, it's on state 1. So as far as that goes, what we can do, and the reason that didn't change right there is because, okay, so now it changed. The reason it didn't change is because I had the reset being held. So standardly, this would be a button that's tied to a HMI. I wouldn't just be toggling bits. So right now, if we wanted to, we could actually say, we could add a instruction to have axis 2 follow axis 1. So with that said, let's say in a jog state, or actually let's do it in the MAM. So let's say we add a rung, and if it is in state, let's copy this instruction, paste it here. If it's in state 2, then we want to go ahead and basically slave drive motion axis 2 off of motion axis 1. So what you want to do is you could gear them together, and you would say you wanted motion axis 2, so virtual axis, and then we'll change this to 2, which would be our slave. Our master is going to be 1. So this would be our control, so I'll call this axis 1 MAG, and we'll say a direction. So we'll quickly go over the attributes of this again. So real quick in instruction help, if we looked at the direction, we would want we either want a 0 if the slave is to move the same direction as the master, which is what we want. You can have it run opposite, you can have a slave run reverse of the current position. I mean, you could change the way this situation worked. In our case, we're going to put a 0. We want it to run the same. You can change the ratio. So say you wanted it to run a double the speed, and you could put it at a 1:2 ratio. You know, we're going to put a 1-to-1. So we'll just put a 1. Slave counts. So if you went down and looked at slave counts, basically you put you would put the slave counts that's used in the specified gear ratio. Again, we just pop that as 1, and then the master reference is the actual, not the command. Ratio format is real. We want to disable or enable the clutch, which we could have. Basically what that is you can electrically tell it to come on or cut off. In our case, we want to disable the clutch. So the acceleration we want to keep at 200. That'll basically match what we have up here. Come back and put our units at units per second. And everything is good for that instruction. We'll assemble our edits. Come back, and at this point right here, we are in the state of 2. So we're actually geared at this point. So if we were to actually look at the program, or the tags I should say. So if we started this into a jog state, actually we have let's go back up, and we have not put this. Okay, so what we should do is I had it at the wrong state, so when I was explaining it, so we can actually look at axis 2, and axis 2 will be moving as well, because it's actually it's actually jogging at the same, or motion axis moving at the same rate as axis 1. So the slave is axis 2, the master is axis 1, and it is actually running via the MAM for axis 1. So as soon as it's done, now this stopped at a position of 400, and this stopped at a position of 500. Now you might ask yourself why, but if we look at the attributes on the servos, we have the homing of virtual axis 2 and the homing of virtual axis 1 different. So the homing of virtual axis 1 is 100 units, and the homing of virtual axis 2 is 0. So at this point, there are 100 position units off. So if we want them to be absolutely perfect, we can actually change the homing of axis 1 or axis 2. So at this point, to get them to both run, so now that it's geared, we can take it back and start running it, and they both keep on running. So they both continue to run, and then to add to that, if we change the speed, they both change speeds. So now we actually have a two servo system changing speeds via one set of commands. So being that we've geared it together, So we've geared it together on our state 2. So as soon as it went into state 2, we said we issued a gear to make virtual axis 2 follow virtual axis 1. And once we did that, we geared the two servos together. So we basically electrically mated virtual axis 2 and virtual axis 1 together. Now in virtual axis 2, it was already in the home state, it was already on, and it was ready to go. Had it not been, then this would have errored out. So being that it was ready, we electrically geared them together, and then we moved them at that point, and now we have the system working together. So at this point, we are jogging both servos off one command, this MAJ, the motion axis jog, for the virtual axis 1. At this point, we can fully control both axes off of one set of commands. So if we want to change the speeds to whatever we would like to change the speeds to, they both work off the one set of commands. So being that, that's a velocity, actual velocity of 30. This is an actual velocity of 30. And say for instance we just wanted to turn them backwards. They both start running backwards. And let's look at the max speed. So the max speed is 200. So let's do this. Let's go 175. So we're running backwards at a negative 165 or 75. So that's axis 1 right there, and this is axis 2 right here. So that gives you an example of a MAJ controlling two servos, being that one is slave driven off another one. It gives you the speed change of two servos being using one MCD command, so a motion change dynamic command. We gave you an example of how to use the MCD command, and we also gave an example of the MAJ, so the motion axis gear. Now you would have to ungear the situation, so you would have to ungear the servo to get it to stop. So you could actually, what most of the time happens is you would just basically stop both of them, and then you would basically break the scenario where it falls out of the state. So we'll shut this one down, and we don't have a shutdown for this one, but we can add it. So what we can do is just copy this ROM, come over here, paste it, change the bits, change the servo that it's going to be changing, okay, so now we can assemble, and that shut down as well too. So if we go back to the top, you see the virtual axis 2 is shut down, virtual axis 1 is shut down as well. So we can reset, we can tell it to home, we can make it move to position, And to double check, it's moving to position. Actually, let's look at what's going on with this one. Okay, so everything should be good. So let's actually cycle that again. So we do a shutdown. That's probably what it was. We had the shutdown still actuated. So we come in and we do a reset. Everything resets. We do a home, both servos. We come down here, verify that our gear happened. Our gear did not happen. So we did actually home, and we did not get a gear though. So in this instance, we did not get a gear. So we would have to come back and modify those controls. This being that we just put the controls together, is probably the issue is we don't have the proper state machine. We probably should have this bit into a position where it follows this as soon as it's ready. So we should have, say for instance, we should have a bit that represents that the axis is good. So in that instance, we should have we could probably use the homing bit, but what I would like to use is the action status. Which these are virtual axes, so they don't have, but they're not in shutdown status anymore. So, well, we can use the servo action right here and paste that in here. Put both axes in there. So now if we came back and we did a shutdown, then we have a full shutdown of both servos. We'll verify that real quick. Both servos are shut down. We should have our axis status gone, our action status gone. We hit our reset. At that point, the action status has come back. We home both, and the enable happened, but again we did not get our gear. So what we should do is we're probably falling out of our gear command. So what's happening here is you should not have to continuously gear here, but essentially what has happened, and I'll explain this, is that we had the PC bit, which is, it went ahead and changed to a 2, so we really should have this happen on a different state. I would say that we should have this on a state 3. And we'll see if that takes care of it. So let's do a shutdown. We do a shutdown. We verify that they did shut down. They did. We do a reset. Come back, reset them. We home them. So they both are home now. Now we come down and we run the first servo until it hits position. So if we look at it, the first servo should be running to a position of 500, and when it hits this position of 500, the IP bit should change to a PC bit and change this state machine into transition it to state 3. Both axis status are on, so our gear should work this time. We should be pretty close. Yeah, so, and that's exactly what happened. So what we were trying to do is actually throw our gear on too quick. So that shows you how quick the motion update rate, or the course rate update rate is. So this, in the attribute of the motion group, the attribute of course rate update, it shows you how quick that actually works, because it beat the scan time and it tried to cut this on and it couldn't. So the instruction went high, but the servo did not cooperate. So at this point, the IP bit, the in process, that means it's geared, is on. So if we jog both of them, or if we jog, cut on the jog bit, then we're starting to jog virtual axis 1, and we should be jogging virtual axis 2, and we are. Now we come down here and we change the speed to 25, and then the speed changes to 25, virtual axis 2, virtual axis 1 changes to 25, and then if we hit we issue a stop command, then virtual axis 1 stops, and virtual axis 2 stopped immediately as well. So what we've done is we've shown the gear, how to gear two servos together. We've shown how to change the dynamic speed. We showed how to the reasoning of what the speed units do as far as in relations to the motion change dynamics. So if you change that again from units per second to percentage of the percentage, then basically it would double. So you want to keep it 1:1 ratio. And again, we'll come back and we'll put a lot better state logic in here for these servos. But this was just a rough, real quick layout of how to do things and to get two servos to work together, and also show at the same time the importance of using the proper bits in the proper place. Also using the proper states. So I think it was good to show what happened and show how we fixed it, and to also show how to find an error if you have an instruction error. So this is kind of why I wanted to kind of build it during this video rather than having it pre-done and just explaining it. I think you get more of an understanding if you actually watch it happen and you actually watch some of the things you may run into and then what you should do to fix them, and then understand why we did what we did. So I hope you got a good understanding of basically how to use a MCD instruction and also how to gear a servo to another servo. And what we'll do is we'll come back and we'll be adding a proper state machine to this. We'll have the motion axis commands for axis 1, 2, and 3 as far as turning on at the same time. Then we'll actually control all 3 of them at one time, and then we'll come back in the next video after that and we'll make an HMI system that coincides with this to actually run the HMI system and show the in relation to when a operator hits a button to do something, that it does exactly that instead of just coming back and toggling a bit. So in this video 4, I hope you got a good understanding of how to gear 2 servos together, and again how to use or change the speed of a servo using a MCD instruction. So I hope this was helpful, and we'll be having video 5, possibly video 6, and this will keep on growing and growing as soon as we add in the other state machine, the other controls, and we'll be adding in the HMI system as well. So hopefully you'll continue to keep watching and subscribe to the channel, and like I said, if you have any comments or want to see anything else or anything you'd like to see, you just feel free to leave a comment and just subscribe to the channel. Thank you.